Right now, somewhere in the darkness, an ordinary-looking rock is doing something extraordinary. It's glowing, pulsing with an otherworldly light that defies everything you thought you knew about stones. And somewhere nearby, someone is about to make the biggest mistake of their life, walking right past it, dismissing it as worthless, never realizing they just abandoned a fortune. Glowing rocks aren't science fiction. They're geological reality, hidden in riverbeds, scattered across hiking trails, and waiting in your own backyard are stones that reveal their secrets only after the sun goes down. These mysterious rocks emit ethereal green lights, brilliant blues, fiery oranges, and haunting purples. And many of them contain rare gemstones and even diamonds worth thousands, sometimes hundreds of thousands of dollars. Before we unlock the secrets of these luminescent treasures, hit that subscribe button and give this video a like so you don't miss our next powerful content on gemstone hunting. And one question before we begin our journey: which country are you watching from? Drop your location in the comments below. This helps us tailor content to the specific glowing gemstones found in your region's geology. Now let's discover the 5 most valuable glowing rocks you should never ignore. Watch to end. I will reveal advanced UV prospecting technique that's real work well. What you're about to learn will fundamentally change how you see the world after dark. Rocks that glow aren't magical. They're performing a remarkable scientific phenomenon that geologists have studied for centuries. This glow, called luminescence, occurs when certain minerals absorb energy and release it as visible light. There are 2 types you need to understand: fluorescence, where rocks glow only while exposed to ultraviolet light, and phosphorescence, where rocks continue glowing even after the UV light source is removed. The most valuable finds are phosphorescent rocks that glow on their own in complete darkness, sometimes for hours after sunset. This luminescence happens because of trace elements trapped within the crystal structure. Impurities that would seem like defects but actually create the magic. Manganese creates yellow and orange glows. Uranium produces brilliant green luminescence. Rare earth elements generate reds, blues, and purples. When you find a rock exhibiting this behavior, you've discovered something geologically unusual, and unusual geology often means valuable gemstones. The same conditions that create luminescent minerals frequently produce diamonds, sapphires, emeralds, and other precious stones in the same rock formation. Why glowing rocks indicate valuable gemstones? Here's what most people don't recognize early. Luminescent rocks are geological red flags, marking treasure zones. The chemical conditions required to create glowing minerals are the exact same conditions that form valuable gemstones, deep underground where extreme heat and pressure reshape Earth's minerals. Trace elements get incorporated into crystal structures. These trace elements serve 2 purposes. They create the glow you see at night, and they often indicate the presence of rare earth minerals and gemstone-forming environments. For example, uranium-bearing rocks that glow green under UV light frequently occur near diamond-bearing formations because both require similar deep earth conditions to form. Rocks containing willemite, a zinc silicate that glows brilliant green, often occur alongside franklinite, which contains rare earth elements worth hundreds of dollars per pound. Calcite that glows red or orange typically forms in marble deposits that may also contain rubies, sapphires, or other corundum gemstones. Fluorite, one of the most brilliantly fluorescent minerals, commonly occurs in hydrothermal veins that also produce topaz, beryl, and tourmaline. Understanding this geological connection transforms your nighttime rock hunting from random searching into strategic prospecting based on proven mineral associations. Essential tools for detecting glowing rocks. Before you can find these luminescent treasures, you need the right equipment. The most critical tool is a high-quality ultraviolet flashlight, specifically one that emits shortwave UV light at 254 nanometers or long-wave UV at 365 nanometers. Shortwave UV reveals fluorescence that long-wave UV misses, making it essential for serious prospecting. Quality UV flashlights range from $30 to $200. But this investment pays for itself with a single significant find. You'll also need a regular flashlight for navigation and a headlamp to keep your hands free. Bring a small portable scale because glowing rocks that feel unusually heavy for their size often contain dense gemstone crystals. Carry a magnifying loupe with at least 10x magnification to examine surface features and crystal structures. Pack a notebook or smartphone to document finds with photos and GPS coordinates. Wear eye protection designed for UV light exposure, as prolonged UV exposure can damage your vision. Include a rock hammer for careful specimen collection, not for smashing rocks open, which destroys value. Bring cloth bags or padded containers to transport specimens safely without causing damage. Finally, download geological survey maps of your hunting area to identify rock formations known for gemstone production. The best locations to find glowing gemstone rocks. Location determines success more than any other factor in gemstone hunting. Rivers and streams top the list because flowing water acts as nature's sorting system, carrying gemstone-bearing rocks downstream from source deposits and concentrating them in accessible locations. Focus your search on gravel bars, inside bends where current slows and deposits heavy materials, and areas just downstream from rapids or waterfalls where turbulent water drops its heaviest cargo. Old mining areas offer exceptional opportunities because miners of the past often discarded rocks they didn't recognize as valuable, leaving treasures for those who know what to seek. Volcanic regions produce fluorescent minerals in abundance because volcanic activity brings deep earth minerals to the surface rapidly, preserving trace elements that create luminescence. Ancient lake beds, now dry, concentrate minerals in layers that you can access by examining exposed banks and eroded hillsides. Desert environments, particularly in the American Southwest, offer excellent visibility at night and host numerous fluorescent mineral deposits. Limestone quarries and marble deposits glow spectacularly under UV light and may contain gemstone-quality calcite crystals. Mountain streams draining metamorphic rock formations carry garnets, sapphires, and other valuable stones that often display fluorescence. The key is researching your local geology before you hunt, identifying areas where the right rock types exist. Gemstone number 1, diamond-bearing kimberlite with blue glow. Let's start with the ultimate prize, diamond-bearing kimberlite that exhibits blue fluorescence. Diamonds themselves frequently fluoresce blue, yellow, or green under UV light, and this fluorescence helps identify diamond-bearing rocks in the field. Kimberlite, the volcanic rock that transports diamonds from deep within Earth's mantle, often contains fluorescent minerals like calcite and dolomite that glow bright blue or orange. When you find a dark, heavy rock near rivers in diamond-producing regions that glows blue under UV light, you may have discovered a diamond-bearing specimen. The United States has several diamond-producing areas, most famously the Crater of Diamonds in Arkansas, where kimberlite pipes reach the surface. But smaller diamond finds have been documented in Colorado, Montana, Wyoming, and even the Great Lakes region, where glaciers carried diamond-bearing rocks south from Canadian deposits. The blue glow you see indicates calcite crystallization under high-pressure conditions, the same conditions that preserve diamonds during their violent journey to the surface. A single diamond-bearing rock could contain multiple small diamonds worth hundreds or thousands of dollars each. The key is recognizing kimberlite's distinctive features: dark, greenish, or bluish-gray color, dense and heavy weight, often containing fragments of other rock types, and that telltale blue fluorescence. Gemstone number 2, Hyalite opal with brilliant green glow. Hyalite opal represents one of nature's most spectacular fluorescent displays, glowing brilliant green under UV light with an intensity that seems impossible from such an ordinary-looking rock. During daylight, hyalite appears as glassy, clear to white crusts on volcanic rocks, easily dismissed as worthless mineral deposits. But shine a UV light on hyalite after dark, and it erupts in otherworldly green luminescence caused by trace uranium content. This is the same uranium that makes Depression-era glass glow green, and it's completely safe to handle in the small concentrations found in opal. Hyalite occurs in volcanic regions across the western United States, particularly in Nevada, Oregon, Arizona, and New Mexico. Look for it coating the surfaces of basalt, rhyolite, and other volcanic rocks near ancient hot springs and geothermal areas. While hyalite itself has modest value, usually $20 to $100 for exceptional specimens, its presence indicates volcanic activity that also produces precious fire opal. Fire opal, among the world's most valuable opal varieties, shows brilliant orange, red, and yellow colors, worth hundreds to thousands of dollars per carat. Fire opal doesn't always fluoresce, but it forms in the same geological environments as hyalite, often in the same rock formations. When you find glowing green hyalite, examine the surrounding area carefully for the orange and red tones of fire opal hiding in nearby rocks. Gemstone 3, ruby and sapphire in fluorescent marble. Marble deposits that glow red, orange, or pink under UV light may contain some of Earth's most valuable gemstones, rubies and sapphires. These precious stones, both varieties of the mineral corundum, form in metamorphic environments where limestone transforms into marble under extreme heat and pressure. The same trace elements that create fluorescence in marble, chromium, titanium, and iron, also color corundum crystals, producing the deep reds of ruby and blues of sapphire. North Carolina's Cowie Valley produces rubies in marble that fluoresces brilliant red, creating a stunning visual effect when you illuminate the rock at night. Montana's Yogo Gulch yields sapphires in limestone deposits that show orange fluorescence. When you find marble or limestone that glows vividly under UV light, you've identified a metamorphic zone with the right chemistry for corundum formation. The fluorescent glow means calcite crystals contain chromium or other trace elements, and these same elements might have colored nearby corundum crystals into valuable gemstones. A single high-quality ruby can sell for $10,000 per carat or more. Sapphires command similar prices for exceptional specimens. Even lower-grade corundum has value for collectors, and as industrial abrasives, the key is recognizing fluorescent marble as a treasure map pointing toward potential ruby and sapphire deposits. Gemstone number 4, emerald-bearing rocks with red fluorescence. Emeralds, the green variety of beryl, occasionally occur in rocks that display red or pink fluorescence under UV light. This happens because emerald-forming environments often include calcite, which fluoresces red when it contains manganese. The association isn't universal, but it's common enough that red fluorescing rocks from known emerald regions deserve serious investigation. Colombia produces the world's finest emeralds, and many Colombian emerald deposits occur in calcite veins that glow red under UV light. While most of us won't hunt emeralds in Colombia, similar geological conditions exist in North Carolina, where the Crabtree Emerald Mine and surrounding areas have produced emeralds for over a century. Rocks collected from streams draining these areas sometimes display red fluorescence, indicating calcite with the right trace elements for emerald formation. Emeralds themselves don't typically fluoresce, but their host rocks might, helping you identify promising specimens for further examination. A single high-quality emerald crystal can be worth thousands or even tens of thousands of dollars per carat. Even flawed emerald crystals have significant value because they can be cut around inclusions to produce valuable gemstones. The red fluorescent glow serves as a beacon, guiding you toward rocks with emerald potential, transforming your UV flashlight into a treasure detector. Gemstone number 5, fluorite with multicolor glow and hidden. Topaz fluorite earned its name from fluorescence because it displays this property more vividly than almost any other mineral. Fluorite glows blue, purple, green, yellow, and even red under UV light, sometimes showing multiple colors in a single specimen. During daylight, fluorite appears as purple, green, clear, or yellow crystals, but its true glory emerges under UV illumination when it transforms into a rainbow of luminescent colors. While fluorite itself is relatively inexpensive, usually $5 to $50 for nice specimens, its presence indicates hydrothermal activity that also produces valuable topaz, beryl, and tourmaline. Topaz crystals, particularly the rare imperial topaz in cherry to orange-pink colors, can sell for thousands of dollars for large, clean specimens. Fluorite and topaz commonly occur together in pegmatite veins and granite formations. When you find fluorite displaying strong fluorescence in riverbeds or outcrops, you've identified an area with the right geology for topaz formation. Colorado, Utah, New Hampshire, and Maine all produce both fluorite and topaz in association. The glowing fluorite acts as an indicator mineral, marking areas where valuable topaz crystals might hide. Search carefully around fluorescent fluorite deposits for the harder, denser topaz crystals that often weather out of the same formations. Understanding fluorescence intensity and color, meaning not all fluorescence indicates the same value or gemstone potential. Learning to interpret fluorescence intensity and color helps you prioritize which glowing rocks deserve the most attention. Brilliant, intense fluorescence generally indicates higher concentrations of activator elements, suggesting unusual geological conditions that often correlate with gemstone formation. Weak fluorescence might mean common minerals with trace impurities, but no particular value. Color matters enormously. Green fluorescence usually indicates uranium or manganese elements associated with volcanic and hydrothermal environments that produce opals, topaz, and beryl. Blue fluorescence suggests scheelite, diamond, or calcite in metamorphic environments where diamonds, tungsten, or marble-hosted gemstones occur. Red or orange fluorescence points toward manganese-rich calcite in areas that may produce garnets, rubies, or rhodochrosite. Purple fluorescence indicates fluorite or certain apatite varieties, minerals that occur with topaz, beryl, and tourmaline in pegmatites. Yellow fluorescence might mean petroleum compounds, uranium minerals, or certain varieties of opal. Multicolored fluorescence in a single specimen suggests complex mineralogy with multiple trace elements, often indicating geologically unusual conditions that produce rare minerals. Pay special attention to rocks showing phosphorescence, continuing to glow after you remove the UV light source. Phosphorescent minerals are relatively uncommon, and their presence suggests unusual trace element. chemistry worth investigating thoroughly. Nighttime prospecting techniques for maximum success. Successful nighttime prospecting requires systematic techniques that differ from daytime rock hunting. Begin your search at least 30 minutes after sunset, when your eyes have fully adjusted to darkness and ambient light won't interfere with fluorescence detection. Move slowly, sweeping your UV light across the ground in overlapping patterns to ensure you don't miss fluorescent specimens. Low-lying areas where water collects during rain often concentrate heavy minerals, including fluorescent species, making them prime searching locations. River edges, particularly gravel bars and sandbars, yield exceptional results because flowing water sorts rocks by density, concentrating heavier gemstone-bearing specimens. Old mining dumps and tailings piles glow spectacularly under UV light because miners discarded vast quantities of fluorescent minerals they didn't recognize as valuable. Search systematically in a grid pattern, marking productive areas with temporary flags or GPS waypoints so you can return during daylight for thorough investigation. Bring a regular flashlight to examine promising specimens up close after you identify them with UV light. Photograph fluorescent displays with a camera capable of long exposures, documenting finds before you move them. Work with a partner for safety in remote areas and to help carry equipment and specimens. Avoid searching during the full moon when ambient light reduces fluorescence visibility. The new moon period offers the darkest skies and best conditions for detecting subtle fluorescence. Safety considerations for UV light prospecting. Ultraviolet light prospecting presents unique safety concerns that require awareness and precautions. Never look directly at UV light sources, especially shortwave UV, which can damage your corneas within seconds of exposure. Always wear UV protective safety glasses designed for the specific wavelength you're using. Extended skin exposure to shortwave UV can cause burns similar to sunburn, so cover exposed skin or limit your prospecting sessions to reasonable durations. Navigate carefully in darkness because focusing on fluorescent specimens can distract you from tripping hazards, uneven ground, and obstacles. Bring multiple light sources in case one fails, leaving you stranded in darkness far from your vehicle. Inform someone of your prospecting location and expected return time, especially when working alone in remote areas. Watch for wildlife that becomes active at night, including snakes, scorpions, and larger predators, depending on your location. Stay aware of property boundaries and obtain permission before prospecting on private land, which can be difficult to identify accurately at night. Check weather forecasts and avoid prospecting during storms when lightning presents serious danger in open areas. Bring adequate water, food, and warm clothing because desert environments that reach high daytime temperatures often drop dramatically after sunset. Carry a first aid kit and ensure your cell phone is fully charged with emergency numbers programmed. Testing and identifying your fluorescent finds. Once you've collected fluorescent specimens, proper testing determines their true identity and value. Start with simple hardness tests using the Mohs scale. Glass has a hardness of 5.5, so stones that scratch glass are at least 6 or harder, potentially indicating gemstone minerals. A steel file tests hardness around 6.5, while quartz at hardness 7 provides another reference point. Weigh specimens accurately and measure their dimensions to calculate specific gravity, a reliable identification property. Most gemstones have specific gravities between 2.6 and 4.0, with higher values suggesting denser, potentially more valuable materials. Examine specimens under magnification looking for crystal structure, cleavage patterns, and growth features that help identify minerals. Use streak plates to test streak color, which remains consistent even when external appearance varies. Magnetic testing eliminates certain minerals like magnetite and helps identify others. Conduct acid tests carefully using dilute hydrochloric acid to distinguish calcite, which fizzes from similar-looking minerals. Research your specimens using mineral identification guides, online databases, and comparison to documented reference specimens. Join local rock and mineral clubs, where experienced collectors can help identify unusual finds and suggest appropriate testing. For potentially valuable specimens, invest in professional gemological testing using refractometry, spectroscopy, and other advanced techniques that provide definitive identification. Cleaning and preserving fluorescent specimens. Proper cleaning preserves your specimen's beauty and value without causing damage. Never use harsh chemicals, acid baths, or abrasive cleaning methods on fluorescent minerals until you've identified them precisely, as many are chemically sensitive or fragile. Start with gentle dry brushing using soft bristle brushes to remove loose dirt and debris. For water-safe minerals, wash specimens in distilled water with small amounts of mild dish soap using soft brushes to clean crevices. Avoid tap water, which contains minerals that can deposit on specimens and dull their appearance. Ultrasonic cleaners work excellently for hardy minerals like quartz and calcite, but can shatter delicate fluorescent species. Never heat specimens to dry them, as thermal shock can cause fracturing, especially in minerals with cleavage planes. Air dry specimens thoroughly before storage to prevent moisture damage and mineral alteration. Display fluorescent specimens away from direct sunlight, which can fade colors in certain minerals over time. Store specimens in acid-free boxes with padding to prevent abrasion during handling. Keep different mineral species separated because softer minerals can scratch against harder ones. Control humidity in storage areas, as some fluorescent minerals absorb moisture and deteriorate. For valuable specimens, consider professional conservation services that can stabilize fragile examples and preserve them for long-term collecting. Advanced UV prospecting, shortwave versus longwave. Understanding the difference between shortwave and longwave UV illumination can dramatically improve your prospecting success. Shortwave UV at 254 nanometers penetrates mineral surfaces less than longwave but excites different fluorescent responses, revealing minerals that don't react to long-wave exposure. Many valuable minerals, including scheelite, powellite, and certain varieties of calcite, fluoresce only under shortwave UV, making shortwave lights essential for serious prospecting. Long-wave UV at 365 nanometers penetrates deeper into translucent minerals and excites fluorescence in species that don't respond to shortwave, including many opals, petroleum minerals, and certain varieties of fluorite. Some minerals show different fluorescence colors under shortwave versus longwave, a property called multi-wave fluorescence that aids identification. Professional prospectors carry both shortwave and longwave UV lights, examining specimens under each to detect all fluorescent species present. Midwave UV at 302 nanometers fills the gap between shortwave and longwave, exciting fluorescence in minerals that respond weakly or not at all to the extreme wavelengths. Portable UV lights now offer multiple wavelength options in single units, allowing wavelength switching without carrying multiple devices. Battery-powered LED UV lights have revolutionized field prospecting with their lightweight, long battery life and cool operation compared to traditional mercury vapor UV lamps. Understanding which minerals respond to which UV wavelengths transforms prospecting from random searching to targeted detection of specific, valuable species. River prospecting strategies for glowing gemstones. Rivers concentrate gemstone-bearing rocks through natural sorting processes, making them prime prospecting locations. Focus your search on inside bends, where slower current deposits heavy materials, while lighter sediments wash away. Gravel bars, especially those exposed during low water, accumulate dense minerals, including gemstone-bearing rocks, over multiple flood cycles. Areas immediately downstream from rapids or waterfalls collect heavy rocks dropped by suddenly slowing water after turbulent sections. Search bedrock cracks and crevices where moving water wedges heavy rocks during floods, creating natural traps for valuable specimens. Pay special attention to layer changes in gravel bars, where different colored sediment layers indicate deposition during separate flood events. These boundaries often concentrate heavy minerals. Rivers draining known gemstone-producing areas carry material downstream from source deposits. The next time you walk past a riverbed at night, remember that fortune favors the informed. Those ugly rocks glowing in the darkness aren't just geological curiosities, they're potential treasures, waiting for someone knowledgeable enough to recognize them. You now possess the knowledge that separates casual observers from successful gemstone hunters. Every glowing rock deserves investigation because beneath that mysterious luminescence might hide diamonds, sapphires, emeralds, or rare minerals worth thousands. Get out there, turn on your UV light, and start discovering the glowing fortunes others walk past every single day. Don't forget to subscribe and share your amazing finds in the comments below.